Okay, warm-ups for today is going to be solving equations with rational exponents. That means your exponents are fractions, or different type of fractions. So we're going to solve these equations like we solved before, except for the only step that's different is when we get to this radical up here, or when we get to this exponent right here, we've got to take the reciprocal and bring it to the other side, just like we were multiplying or trying to get rid of our fractions. So with this first question, we see 3 times 2x plus 6 raised to the 1/4 power minus 6 is equal to 0. So we're trying to get this parenthesis by itself. So we need to either add or subtract, multiply or divide, depending on what the situation gives us. Here, a minus 6. So we're going to go ahead and add 6 to both sides. That's going to give me 3 times 2x plus 6 raised to the 1/4 power is equal to 6. And what we do from here, since this is 3 times this parenthesis, we do not distribute because it's protected by this 1/4. So we're going to go and get rid of it by dividing 3 into both sides. And that's going to leave me with 2x plus 6 raised to the 1/4 power is equal to 2. Here, since the parentheses are by themselves, we need to get rid of this fraction exponent. So to get rid of this fraction exponent up here, you would have to raise it to the 4/1 power, which is just raising it to the 4th power. So what I do to the left side, I must also do to the right side, so I'm raising it to the 4th power. That leaves us with 2x plus 6 is equal to 2 times 2 times 2 times 2, 4 times 4, 16. So that leaves us with our two-step equation to solve right there. You're going to subtract 6. You have 2x is equal to 10, divide by 2, and you have x is equal to 5. Should come out quite nice. That takes care of that question. What happens if it's a 1/4? So the next question is, what happens if it's something other than an easy fraction, like 1/3, 1/2, 1/4? What if we have an improper fraction, or what if we have any other kind of fraction? How do we deal with it? So that ties into having to go to radical form versus exponential form, and we'll deal with that right now. So the question is 3x plus 21 raised to the 3/2 power is equal to 729. So in order to get, this is already by itself. In order to get rid of this exponent right here, we need to raise it to the 2/3 power so it cancels. So that means I'm going to do the same thing over here, raise it to the 2/3 power. So what that means at this point, we want to go ahead and change it from exponential form to radical form. So this is going to give me 3x plus 21 is equal to the cubed root. Our little rhyme is the number in the back goes into the index, we call it the crack. So the number in the back goes in the crack right there. This becomes the number that goes inside the index. So now we have two 729s that we need to break down using prime factorization. Well, 729 is going to break down into 3 and 243, 3 and 81, 3 and 27, 3 and 9, 3 and 3. So that means I'm going to have the same number of 3's, 1, 2, 3, 4, 5, 6, for this one as well. 1, 2, 3, 4, 5, 6. So I'm not going to write the same numbers again. This is the same as that, so I have 3 inside the index, which means I need 3 of a kind. There's 1. There's 2. There's 3. There's 4 of them. So 3 times 3 times 3 times 3. 1, 2, 3, 4 gives me 81. So I have 3x plus 21 is equal to 81. I'm going to solve that two-step equation. Minus 21 on both sides. It's going to give me 3x is equal to 860 divided by 3. And I have x is equal to 20. That takes care of our warm-up for today, solving equations with rational exponents.